So this is the first question that you sent me, Maddie, where it's asking for a critical value for this one proportion z-test. And you can see that I've inserted a picture of the table of critical values for the normal distribution. In this particular problem, you have chosen to do a right-tailed test because of your greater than alternative. And so that basically means that you believe that your results will be above the claimed proportion of 72%. So you believe your results will be in this tail. Now you'll only reject the null if your z-test statistic ends up in this tail that has an area equal to alpha. Alpha is the level of significance, which in this case is 0.10. Well, the table of critical values only gives areas below. So if there's 0.10 area above, then that means there is 0.90 area that is below. So to find our critical value, what we basically have to do is we have to look in the body of this table and identify a value as close to 0.9000 as we can possibly get and find the corresponding z-score. And we can see that that value is right here. The 0.8997 is the closest that we can get to area below of 0.9000. That we can see is in the 1.2 z-score column with the 8 in the hundredths place. Therefore, our critical value, we often refer to it as z star, is 1.28. Now I do want to mention that there is another way to do this. I believe you have a graphing calculator, and you have a command on your graphing calculator that does the very same thing, and it's a little bit easier to use. That command is the inverse norm command. It can be found in the distribution menu, which is under second variables. An inverse norm is the third option there. So what you give with this inverse norm command is the area below, and then you give the mean, and if you want a z-score, you use 0 for your mean. And then you give the standard deviation, and again, if you want a z-score, you give 1 for your mean. So what this basically means then, again, back to my picture, if we are only going to reject the null in this right-tailed test, if we end up in this tail that has an area above it equal to, or area in it equal to 0.10, therefore an area below it equal to 0.90, we will do so only if our z-test statistic is out beyond or above 1.28. So 1.28 standard deviations above the claimed mean.